I have made up your test. I have made up your pretest. I have made up your lessons. And I'm asking myself as your teacher, or have I given the students everything they need to be prepared for the test? And I think that I have. I'm just not sure that I have. And what I'm scared of is that somehow you'll make a mistake using this normal CDF function on your calculator. The thing that concerns me so much is that we did begin in our discussion of probabilities and normal distributions by using the table, which is important that you know how that can be done. But we segued over time into using the calculator. And I suspect that you guys became very comfortable with how to use the calculator. And in so doing, you didn't necessarily say, well, if I see this, I should do that. And if I see this other thing, well, I got to make sure I do that other thing, and so on. So I just want to go through distinctions in when and how to use each of these functions in terms of, your setup, whether it's a sample mean central limit theorem application or just a basic probability type application. And also, what if it says less than a particular number, greater than a particular number, or between two numbers? So I want to cover all of those possibilities here and really get the point down pat. Okay, so this is a sheet I just made up that I am going to use for this video purposes, and I'm obviously putting the video up on Moodle to make sure you're prepared for anything that comes your way with the normal CDF type of function, normal distributions, normal curve questions that you're likely to see on the test. Okay, this might be overkill for some of you, but it also might help some of you, and I really want to make sure I've covered this in its entirety. We used to like to say that anybody who says practice makes perfect is a liar. Perfect practice makes perfect. That's the truth. So this is really perfecting our practice. So there are some conditions that impact exactly how you use the second VAR's normal CDF in your calculator. The first is this. Are we talking about a normal distribution, a basic probability situation, or is this an application of the central limit theorem and sample means situation? Here's how you tell the difference and how you input data into second VAR's normal CDF based on which you're given. And there is a very, very important distinction here that you've got to be looking for and you've got to be prepared for. So on a basic probability normal distribution, like this first question in this slightly grayed in area here, based on data from the National Health Survey, women between the ages of 18 and 24 have an average systolic blood pressure of 114.8, standard deviation 13.1. Systolic blood pressure for women between the ages of 18 to 24 follow a normal distribution. If one woman from this population is randomly selected, find the probability that her systolic blood pressure is greater than 120. If 40 women from this population are randomly selected, find the probability that their mean is greater than 120. Okay, so there's a big difference between A and B. In letter B, you see it says find the probability that their mean systolic blood pressure. That is an application of the central limit theorem. I don't want to consider B right now. I only want to consider A. That's why I come over here and I put A down. For A, I would use second VAR's normal CDF, and I want to be greater than 120. So I begin at 120, and then I go up and up and up and up and up forever and ever. And the way you tell the calculator forever and ever is 10 to the 99th. Then I put the mean, which is 114.8, and then I just put the standard deviation, which is 13.1. That's it. I don't go any further than that. That's how I handle A. I suspect that every single student in the class is very strong at that. At least everyone that's been practicing on a calculator with these last lessons. Okay, I'm going to stop at that point in time because we're chewing through memory here, and then I'll go into the next application of what I want to get across to you.